Hello, this is Miss Lee, and today we're going to talk about modeling algebraic expressions. Now you already know what an algebraic expression is, something we've talked about before. An algebraic expression has to have at least one variable with at least one operation. So this example over here, x plus 3, we have an operation, which is addition, and we have an x variable. This would be considered an algebraic expression. Here we have 7y. Remember, when you have a number next to a letter, that invisible operation is multiplication. So this is really 7 times y. So we have an operation of multiplication and we have a variable of y. This makes this an algebraic expression. So today we're going to learn how to model these algebraic expressions, and we're going to use algebra tiles for our modeling. So if you look down here, these are the x tiles. The x tiles are called x tiles, but they represent any variable that you have. It could be x, it could be t, it could be p, whichever variable it is that you're modeling. And they are rectangular in shape. They can be vertical or they can be horizontal. It's your choice. If it's a positive, you'll put a positive symbol. If it's negative, you put a negative symbol in the tile. Then you have your unit tiles. These represent your constants, those that are just numbers. So if you have a positive 2, you would need 2 positive unit tiles. Or if it was a negative 2, you would need 2 negative unit tiles. Then we have this tile right here. This is the x squared tile. It's whenever you have a variable that is squared. We're not going to use this in 6th grade, so I'm going to put it back over here. I just wanted you to be familiar with what it did look like. Okay, let's get started. Our first expression, algebraic expression that we're going to model is x plus 3. And this is what the model would look like. You have one x tile, so that would be a positive rectangular tile that represents x. And you're adding 3 positive units. So you would need 3 positive unit tiles. And that's all there is to it. This represents x plus 3. Okay, t minus 2. This is what the model for t minus 2 would look like. T is our variable. There's only one t, so you only need one x tile. It is a positive t, so you put that positive symbol there. And then it's minus 2, which is the same as 2 negatives. So this time we need 2 negative unit tiles. And this would be t minus 2. 3p. So we've talked about this. We know that a number next to the variable means multiplication. All this is really saying is that we need 3 p's, or 3 x tiles, and they're positives. So this would be 3p, the model for 3p. 7y, can you guess what this one would look like? Yep, it's the same as 3p, except for instead of 3 x tiles, you need a total of 7 x tiles. This would represent 7y. Again, you could put them, use the horizontal x tile. What about if we're dividing? M divided by 4. How are we going to show that? This is a little bit different, but it will probably remind you of something. There's only one m, so you only need one x tile, and we want to divide it into 4. We want to cut it into 4 parts. And this is what it would look like. Kind of reminds you of a fraction bar, right? A fraction strip where you cut it into fourths. That's what you're doing here. So this would be x divided by 4. Can you guess what this one would be? Z divided by 3. Yep. There's your x tile, and you would just divide it into 3 parts. So this would be z divided by 3. What about our last example? X plus 3 plus 3x minus 4. Take it one part at a time. What do you see first? X. How many x's are there? 1. So this would be our x. Then we have plus 3. 3 units, they're positives, so we need 1, 2, 3 positives. Then we have 3 positive x's. So we need 3 more x's. And then minus 4 means 4 negative units. And this would be our 4 negative units. And that's how we would model this long expression here. Okay, now we want to write an algebraic expression for the model and then simplify the expressions by combining like terms. Okay, take a look at what we have. What do you see first? You see two positive x tiles. Then we see one positive unit tile and then another positive x tile. So the expression would be 2x plus 1 more x tile. And you can simplify this by combining the like terms. So we could actually, if we had the tiles, move them around, put all of the x tiles together, and it would give us a total of 3x's plus the one positive. What about this one? What do you see here? I see 3 positive x tiles, 1 negative x tile, and 2 positive unit tiles. So the expression would be 3x minus x plus 2. And if you'll recall from our integer unit, we learned that a positive and a negative, what do? They make a zero pair, so they cancel each other out. So we can remove it, and what are we left with? We're left with 2 x tiles and 2 positive unit tiles. So the simplified expression would be 2x plus 2. How about this one? Well, think about what you see. See 2 negatives, they're units, 2 positive x tiles, 4 positive unit tiles, and 2 positive x tiles. So you just write it like you see it. Negative 2 units, here's your negative 2, plus 2 x's, here's your plus 2 x's, 4 positive units, there's your plus 4, and 2 positive x tiles, plus 2x. And again, we can combine all the like terms. We want to simplify it. So I have a negative and a positive. I have another negative and a positive. And we know that these cancel each other out. They make a zero pair, so we can pull them out. Then if I put all my x tiles together, all my units together, what do I have? I have 4 positive x tiles and 2 positive unit tiles. 4x plus 2. Okay, and now you're ready for your independent practice.